On today's episode, occasionally I like to mix things up on my channel and show you something that somebody has brought me to repair. Today we're looking at this Smart Gyro Speedway electric scooter, and clearly it's taken a tumble and it's broken the LCD screen. The scooter still functions. You can switch it on. You may barely make out a few characters on the display there, but it's pretty much shot. However, beep the horn and things, and it does actually move along, but you can't see your speed or anything clearly. This is a generic type of display, the S866, used on many electric bikes and scooters. I've purchased a replacement one. Now the challenge is how to fit it. Let's see what we can do. The unit itself is easily removed with a 3mm hex key. It's just the one screw. The next challenge then is finding out how long this cable is. On the replacement unit, I guess it's nearly 2 meters. I hope it doesn't go all the way down into the base of the unit, because that would be a royal pain. But experience tells me that somewhere along this line there will be a connector. Let's look. Already uncovered these connections here, and that's not the one that we want. At last. Just pull on that connection, and there we can see the connector with 5 pins in it. Replacement unit doesn't have one of those. What we're going to have to do, I think, is to cut this off and splice the wires together. Just a quick tip on these type of connectors. I actually repaired a folding electric bike that the display didn't work on at all. I found that the cable loom was stretching when the handlebars were folded down and actually pulled this connector apart. Always worth checking. Thankfully the two units look the same, and it's comforting to see the correct voltage on the back there. These are available in 3 different voltages, I think 24 and 36, but the one that we needed was 48 volts. That's good. Everything else is identical apart from the cabling. We know this guy has a 5-way connector, and here we have a 5-way connector and a 2. I understand that these 2 are used to control a light via this module, whereas the scooter has its own light. I guess we're going to have to remove those, and we'll just have those 5. As an extra bonus at the end of the video, I'm going to take this guy apart just to see what's inside, as that's the sort of thing that I do. Let's cut this cable now and have a look at the wires inside. As predicted then, just the 5 wires inside, and they are the same colours. However, being a skeptic and previous experience, I'm going to plug this back into the bike and just check the voltages. When plugging this back into the bike, between the black and the red was the battery voltage. There was no voltage on here. This is the control line from the display to the controller itself, and these are receive and transmit. You can see those pinouts and a description of the functions of this display on the screen now, and as always there'll be a link down in the description where you can grab that. I'll go ahead now and match these colours up, then we will see if everything is correct. I've connected the new display and powered it on, and to begin with everything looks good, but after a while we see this exclamation mark. The exclamation mark means there's a communications error. The display is not communicating with the main controller. Time to start troubleshooting. First thing I'm going to do then is to test the original controller. Okay, we know the LCD is broken, but the rest of it functions as the scooter works. And now it doesn't. Oh dear. I've connected it up just to a little piece of circuit board and put some pins in so that I can test. we have our 48 volts here on the red and black, and also my oscilloscope ground. Then we have the blue connection and the receive and transmit on the yellow there, which I'm probing on the oscilloscope. Let's switch on my power supply and we can just check that there is 48 volts on there. Nothing on the blue pin. 0.1 of a volt on the transmit and 4 volts on the receive. If I now switch the display on, we can see here that it's transmitting something. That's good news. Clearly again 48 volts. And now on the blue connection, as we expect to connect to the controller, we have our 47 volts. We can see that it's transmitting on the transmit, which is the yellow. 6 volts on the receive. That is what we expect to see. Now I'm going to wire up the new controller that I bought and test that. Checking the new LCD now. Once again, turn on my power supply. 48 volts. 3 volts on the blue. That's not the same. Nothing on the yellow. And 3.9 on the receive. So my suspicions are aroused already. So turn the display on. See it there. .48 volts. The blue, 6 volts. The yellow, 47 volts. And 6 volts. Clearly then, the yellow is not transmit. The yellow has got 47 volts on it, which is the controller power. I can only hope and pray that sending that voltage up the receive pin of the controller has not blown it to bits. Just for the avoidance of doubt, if I move my probe, we can see now the transmitted data, which should be on the yellow pin, is in fact on the blue pin. I can only assume that this is some error in manufacture. The site where I bought this unit, and links down in the description, there are people saying that it works fine. Well, clearly theirs must have been wired correctly. I'm going to wire it back up to its connector now, and if you'll pray with me, we'll see if it will work. Oh great gods of electronics, help me now in my moment of need. So far so good. Just wait a few seconds and the communication error has gone away. We flip through the screens, we can see E00, which means 0 errors. Excellent news. This being a generic display, there are a number of parameters that need to be set for the scooter. We press and hold these. One is just the level of the backlight, not interested in that. Number 2, the mileage, or kilometers, or in kilometers. 3 is the voltage, so 48 is correct for our scooter. Sleep time we're not interested in, that should be 0. Power assist, this selects the different levels, and 1 to 3 is okay. 6 is the wheel diameter, which is currently set to 20. This being a scooter, that should just be 10. That's okay. 7 is the number of speed magnets, which I believe should be 30. 8 is the speed, 100 being no limit. And finally 9 should be on 0 as well. That's the 0 start. Again, being a scooter, it needs to start up straight away. Excellent. I guess the only thing left then is to take it for a spin. On the left of the screen then you can see my cycle GPS to compare the speed against. Obviously being a GPS it will be lagging behind the scooter speed, but it definitely looks comparable. Over the hump And let's open her up. Up to a maximum speed 31 kilometers per hour. Not too shabby. Everything working fine.